All right, so now we will have the last team, which is the City University of Hong Kong. So you will also have 8 minutes for the presentation. Thank you.
So good morning, good evening, judges. So today we're going to introducing you AI, shopping assisting system with immersive navigation for visually impaired individuals. So first, I would like to share a story begins with you. With our friend, Mr. Comma Chan is Hong Kong's 10 outstanding young person, which is also a visually impaired friend.
一個後天失明嘅視力朋友啦，我相信係有獨立、可以自主、好自由、平等地去購物。咁但係會唔會咧，因為睇唔到嘢咧，變得有限制啊，同埋呢個種族啦，嗰個嘅價格啊，或者呢個嘅位置。
In Hong Kong, there's around 200,000 people, visually impaired people, including 10,000 blinds and also 134 people in Asia. And the employee rate is under 50% with a low average income. And as you can see, among all these problems, economic hardship and social isolation are mainly why you cannot see them often on the street. And so if there is any problem, if there is any solution that can help them, is shopping. For example, save money by comparing price, and also most importantly is to enhance their self-identifications. But the problem is that the visually impaired cannot shop independently. Not only visually impaired, also retails fills the market gap to promotions. And also, the existing tools are expensive with a high barrier to the market landscape.
So we are offering AI, which offer our user a low-cost, immersive, and sustainable solution. So our mission is to deliver implementable, useful, and low-cost tools for disadvantaged group like visually impaired, and allowing them to shop everywhere they want. And finally, we want to build an inclusive society. So AI is an easy solution, which contains 2 parts. The user part with mobile app and earphones, and the retail's part with an admin platform, which both connect to an AI server. So let me explain everything to you by doing a real-time demonstration. So, if someone is in front of me,
get some Fuji apples?
Yeah, why not? Okay.
All right, let's head to the apple section. Just follow me by the surrounding sound. You are close to the target area. Let me switch you to searching mode. Just follow the sound and find the apple on the shelf. Great job. Demo completed. Good luck.
So as you can see, the screen shows the real-time detection of the results, and will guide the user by using the surrounding sound instructions. So you can feel the direction, you can hear the speaker in left side and right side, which is simulating the earphones left side and right side. So, and during the demonstration, you may find that there's some innovations, including the first one, the surrounding sound instructions, which provide an XYZ movement, immersive experience. You can feel the direction. So if from left side, you know if you are going to the right side. So second is the low-cost indoor navigation, which offer indoor navigation using IMU sensor, which is built in the mobile. And we use Arcotech to correct the IMU error to provide a very accurate and low-cost indoor navigation. And the third one is the 3D memory map. So we store and predict the object position by reduce the detection rate. So first we detect the object, and then we predict the movement by using the IMU results. So you can see, we build a stable and low-cost result. 3D memory map only requires 2 to 5 FPS. And last one is the most important one, the effective object detection structure, which can eliminate this model training cost. So we combine CNN model and image similarity model. CNN model will detect and localize all the objects, and then crop into different objects and compare with the image vector in the database. So when there's new product addition joining to the market, we only need the number of the product picture. We don't need a lot of picture for training. So you can see we have successfully built a useful, low-cost, and implementable solution by using the 4 innovations. So you can see there's guardians function, which gives instruction to our user, and also query function to provide information. We use expert system for the guardians function. We want to make sure everything is under control and safety. AI agent is more effective for providing information. Of course, we care about the safety, so we use UNet to provide obstacle avoiding system to our user.
So instead of the unity logic, we also have a unit business model. So AI works with end users and shop partner, and we provide the app to users and while the admin platform to shop partner. And the admin platform is an editing and monitoring system which allow custom map data, update product data, and even getting a marketing result. And we want our users to enjoy our services at a reasonable price, so we provide a free plan to encourage people to join. But for the full version, we only charge them monthly 39 Hong Kong dollars, and for the shop partner, in monthly 5,000 of Hong Kong dollars.
So why AI? Let's hear how a user says.
咁啊，有啲小朋友我大家嘅，咁佢如果買到啲食物俾個小朋友，係啦，同佢哋一齊去相處，嗰啲小朋友會覺得好中意喎，爸爸中意睇到嘢喎，但係點咧？好似咁嘅家長中意，佢有冇買驚喜啊？買我中意食嘅食物啊，佢爸爸我啊，咦，都幾好喎。
So for retailers, you can gain more customers and better reputation and market data, of course. And then before, they need to find by touching every stuff, but now we convert vision into hearing, so they can feel the environment. We can extend to school, to hospital, to every place you can expand to. And we can even combine personal AI agent to build a full functional AI agent for visually impaired and unleash their potential capabilities. Imagine we switch the function of shopping to others, like cooking, gardening, education, 3D, 2D design, by using our vision and instruction technology. You can see unleash the potential capability in even the job market. Close to 300 million people will be affected by this, and the economic and society will be benefited by the AI. So you can see we provide contribution and also profit to the society, and it proves that AI argument rather than replace human.
咁啊，最後咧就係我覺得如果一個小朋友先，佢可以點樣去選擇？喺一個社會人與人之間嘅關係咧，會打開咗。
And we spent around 2 years to develop on this project. We have won an ICT award and a PICTA. But after joining the city, we have tried different solutions, including the smart glasses, smart ring, everything. But we found that the earphone and the mobile app is the most fitable solution to our project because it's low cost. We want to make sure it's implementable to the market. And we believe that the purpose of engineering is to improve life for everyone, not just for us. Thank you.
Right, thank you very much. So now we'll pass the time to the judges for the 12 minutes Q&A sessions. Thank you.
Okay, thank you for your presentations. It's very interesting. In fact, I find there is a blind spot in your presentation, which is about 3D memory map. In fact, it's different in different situation, occasion. For example, the mapping of supermarket is different from the mapping of a shopping mall, for example. There may be changing of the product positions or their setting, so it may require constant changing of the 3D map. So the maintenance of it, I cannot see you have added the price for developing and maintenance of the 3D memory map. This is my first question. My second question is that how would you guarantee that your AI platform could operate in a noisy and crowded environment, say within a supermarket? It's usually very crowded in some areas, and maybe hard to even hear people talking, let alone your AI platform.
So for the first question about the 3D memory map, so maybe it's a little different with your thought. So it's not a map for indoor navigation. Instead, it's a technology that helping our system to do object positioning. So with indoor navigation, we use Arcotech and the mobile built-in IMU sensor and a compass. So we use this for the indoor navigation part. So there's also a main platform for the retails, you can see. So they can use the admin platform to update the map data. And we can even connect with their online shop, like this. You can see our effective object detection structure only required 1 to 2 images for each object. So we can just connect with their online shopping mall, and then we fetch the image. They don't need to train for it. And the 3D memory map, the purpose of 3D memory map is to reduce the computing cost of object detection. Because as you know, object detection requires a lot of computing costs. Yep. Okay, so for this two side of picture, you can see that the right side is normal object detection results. You require around 10 to 15 FPS to provide a very stable result for doing positioning of the object, not for the indoor navigation, just for searching the object, like this. But with our 3D memory map, because the system will remember the position of the object detected by maybe 5 frames before, and then we will predict the movement by using the IMU sensor. So that's how we can implement this with 2 to 5 FPS. So you can see for the server side, the process cost will become very lower than the normal solution. So that's how 3D memory map works. Yeah. And the second question is, can you repeat again, please?
Could you describe, because it feels like there are a lot of pieces, could you describe what are all the components? You have the headphones, the person needs to hold a mobile phone, you have 2 tags on, is that for every SKU? And then you also have the memory map on the server side. Could you just put everything together?
So for the SKU, it detected by our detection model. It doesn't require the Arco tag. Arco tag is only for the indoor positioning. So when the mobile detects the Arco tag, we will know the relative position of the user. And then the earphone is to provide a surrounding sound to our user, to guide them to go forward, turn left, turn right. Because if you use the traditional voice instruction, I tell you to go straight, turn left, turn right, you don't know where to go. It's quite confused to the user. So we use surrounding sound. Yeah, you may have heard about the 8D music, similar technology. It's an old technology. Yeah. And for the environment, because the last judge has mentioned about the environment noise. I'll also answer about this. For the environment noise, nowadays the earphone usually have noise cancelling functions, and maybe we can also implement it. It's not a really difficult technology. Yeah.
It's always bold to do live demonstration. Thank you for the effort. I think obviously for human factor, right? So the enjoyment of shopping, the human-to-human connectivity, the fact that you go about and do the physical shopping is one thing. But for visually impaired people, functionally, if they want to do shopping, most of the shopping should happen with convenience. So have you thought about having an alternative where it is just using mobile phone, go online, and with the accessible website, you can actually order most of the things that you need on a daily basis with online delivery. Yes. Now, you can still enjoy 5, 10, 20% of the shopping physically. Now, I think that would be a more complete solution if we were to serve the whole population on visually impaired.
So they just always ask about this question in other competition. They always go, why they don't just use online shopping, right? Well, online shopping is very convenient, but we can also use online shopping, but we always go shopping in reality. Why? Because maybe we want to talk with people, we want to interact with people. And we have also mentioned that visually impaired, they are facing some social isolation. They would like to talk with people. So we are providing an opportunity for them to learn more about what is happening in the society. And they can also get promotions from the retailers, right?
Yeah, I think the value proposition is much more credible for you if you have the foundation of online shopping and then on top have this, because this serves the complete needs. So it's not a black and white 1 or 0 situation, right? So your argument is totally accepted, but obviously for convenience, practicality rules, right? So credibility of the overall proposition would increase, actually.
So actually, that's a very good suggestion. Maybe we'll do this in the future, right? We can combine it with our structure like this. You can see we can switch the model. Maybe we can switch one for the online shopping to provide a more immersive experience. Maybe using VR, right? We don't know because there are many possible. But if we have time, I would like to show the demonstration again because there's some problem just now. Okay.
We were told that you have 4 minutes, so if you can fit it in.
Can you see the position, the 3 points? You can see it's moving, right? Okay, because there's a person in front of me, so it's alerting me. There's danger. Okay. So how can I find the target object? It will provide me surrounding sound instructions. For 3 minutes. Also freeze for doing that real-time demonstration. But it worked, okay. Okay. Yeah. So you can see the surrounding sound. We lost connect with our speaker, but it's okay. You can still feel it. I use my hand. I search for the object. Left. And then I found it. That's how it works, basically. Yeah. So we'll keep improving this system.
Right, thank you, City University, and also thank you, judges, for your question.